Okay, now let us define simple pole and double pole. You see, a pole of order 1 is called a simple pole. A pole of order 1. Why do we say this equation or this function is a pole of order 1? F of z is equal to z by z minus 2. Okay, z by z minus 2. And how will you find the pole? Equate the denominator to 0. Okay, equate the denominator to 0. Z minus 2 is equal to 0. Therefore, Z is equal to 2. Z is equal to 2 is called as simple pole because 2 comes only once. There is no repetition of 2. So, when you come to the second example, a pole of order 2 is called as double pole. A pole of order 2 is double pole. You see, here also let us equate the given function. F of z is z by z minus 2 the whole square. So now equate it to 0. Z minus 2 the whole square is equal to 0. This implies z minus 2 is equal to 0. Z is equal to 2 times. Okay, twice. Why do you say twice? Because you have a square, right? You have a square. Since you have square, z equal to 2 comes 2 times. Therefore, we say it is a double pole. If the root, if the z value come 3 times, then it is a triple pole. So, likewise, pole of order m. If it is repeated m times, then we say it is pole of order m. Okay, then we say it is a pole of order m. So, here z equal to 2 is a simple pole because its order is 1. Here z is equal to 2. Z is equal to 2 comes twice. Therefore, it is a double pole. Okay. Find the poles of poles and residues. Okay. Find the poles and residues of f of z is equal to 2z minus 3 divided by z minus 3 into z plus 4. Poles, consider z minus 3 into z plus 4 is equal to 0. So, how to find poles? By equating denominator to 0. So, we get z minus 3 is equal to 0, z plus 4 is equal to 0. Z minus 3 0 implies z equal to 3. This implies z equal to minus 4. So, z equal to 3 and minus 4 are simple poles. What do we call it as simple poles? Okay, this is simple poles because it is of order 1. No repetition is there. 3 comes one time, minus 4 comes one time. So, it's a simple pole. So, after finding pole, now let us find the residue. Okay, let us find the residue. For simple pole, we have learned the equation of the residue. For simple pole, residue f of z at the point A is limit z tends to A, z minus A, f of z. So, now at the point 3, okay, so at the point 3, that means A is 3. Let us consider the residue equation. F of z tends to, instead of A, you substitute 3 because we are finding residue at the point, at the poles we are finding the residues. What are the poles? 3 and minus 4. So, we find, let us substitute 3, limit z tends to 3, z minus 3, f of z. Limit z tends to 3, z minus 3. What is f of z? F of z is our question. F of z is 2z minus 3 by z minus 3 into z plus 4. So, substituting that, z minus 3 will be cancelled. We get this. Now, z tends to 3. Instead of z, you substitute 3. 2 into 3 minus 3 by 3 plus 4. So, substituting that, we get the answer. That is 3 by 7 is the residue. Now, at A is equal to minus 4. So, minus 4, let us substitute minus 4 here. A minus 4, z tends to, limit z tends to minus 4, z minus of minus 4, minus of minus 4 plus 4, z plus 4, f of z. So, we get this. Now, f of z is our question, we will substitute it here, cancelling z plus 4. Now, instead of z, you substitute minus 4, 2 into minus 4 minus 3 by minus 4 minus 2. Minus 4 minus 3. Okay, f of z here, the denominator is z minus 3. So, you can make it as minus 3. Okay, this is z minus 3. So, minus 4 minus 3, that is minus 7. So, our answer is 11 by 7 here. Okay, next question you can try this on your own. Okay, equate the denominator to 0, find the poles. These are simple poles because there is no repetition. Then you can find the residue similar to the previous question. At -2 and at 1 you have to find. Okay, at you can make it as -2. This is not +2. This is -2. A is -2. Instead of A you substitute -2. So you get this minus into minus +2. So cancelling, then for Z you substitute 2, you get the answer. Then second value, it is Z equal to 1. So that also you can find out. You can follow the same steps to get the answer. Okay. Next question, find the poles and residues of Z e power Z, this is e power Z, divided by Z plus 1 whole cube. Okay, Z plus 1 whole cube. So equate the denominator to 0. Z plus 1 cube. Z plus 1 equal to 0, Z equal to -1, 3 times. Okay, cube means it will be repeated 3 times. So we have a pole whose order is 3. Okay, pole whose order is 3. So that means M is equal to 3. We have learned the residue equation. After finding the pole, we have to find the residue. So we know residue is given by this equation, right? Residue is given by this equation when it is of order M. So now residue is 1 by M plus 1. Okay, residue, this is M minus 1. M minus 1. Okay, M minus 1 factorial. 1 by M minus 1 factorial, limit Z tends to A, d M minus 1 derivative. D M minus 1 d power M minus 1 by d Z power M minus 1. Z minus A whole power M into f of Z. Okay, into f of Z. Now we know what is M value. M is 3 because pole is of order 3. So instead of M we can substitute 3 in the next step. Okay, we will substitute 3. So M is 3 and A is -1. So Z tends to -1. Then here d power 3 minus 1, dz power 3 minus 1, z minus, so let me write that formula again. So here actually this is m minus 1, right? This is m minus 1 factorial, and this is z minus a power m, this is dz. So now m is equal to 3 and a is equal to -1. M is order. Pole at the point, what is our first value? Z equal to -1, right? So at the point -1 we are finding. That means we have to take it as A as -1. So here 1 by 3 minus 1 factorial, limit Z tending to -1. Okay, Z tending to A. What is A? A is -1. Z tending to -1. D power M minus 1. 3 minus 1 by dz power 3 minus 1. Then here Z minus A is -1. So Z minus into minus plus 1, the whole cube, whole power M, whole cube. Z, this is our f of Z, that is our question. Okay, our question is Z e power Z by Z plus 1, the whole cube. So now 1 by 2 factorial, limit Z tends to -1. We have to, 3 minus 1 is 2. So this becomes d square by dz square, because we have to subtract d square by dz square, then the remaining term. Okay, so that we get this 1 by 2 limit, this is limit. Okay, 1 by 2 limit z tends to -1, d square by dz square, d square. Okay, d square by dz square, z e power z e power z. Now what we have to do, we have to differentiate this twice, because you have square, differentiate 2 times. D square by dz square means you have to differentiate 2 times. So d by first derivative you can apply uv form. Z u into v dash, u into v dash, v into u dash, z into e power z plus e power z into derivative of z is 1. Okay, into 1. Now again the one more time we have to differentiate. So what we do is we differentiate once again. So differentiating once again, this is uv, and this here no change. Derivative of e power z is e power z, but here you have to apply uv form. U v dash plus v u dash. Z into e power z, derivative is e power z, plus e power z into derivative of z is 1. Okay. Now e power z we have, here no change, okay. Derivative of e power z is e power itself. So now multiplying this we get e power z into e power z plus e power z 2 e power z. So next step we may get this, okay. Z e power z plus 2 e power z. So now limit z tends to minus 1. So instead of z you put minus 1. Minus 1 e power minus 1 2 e power minus 1. So now adding these two, 2 e power minus 1 minus e power minus 1 is e power minus 1. So 1 by 2 into e power minus 1, 1 by 2 e, okay. So here we get 1 by, this is 1 by 2, okay, this 2, 1 by 2 e raised to minus 1 because z is minus 1. So you have to substitute z as minus 1. The e power minus 1 is, when it comes to the denominator, 1 by e. So our answer is 1 by 2 e, okay. 1 by 2 e is the answer. So next question, finding poles and residues, you can try it on your own, okay. 1 by z power 4 minus 1. So here all the poles are symbol pole. You see, plus or minus 1, root of minus 1 is plus or minus I. So you get 4 values for z and they all are symbol poles, 1 minus 1, I minus I. So you can do it one by one. You can follow the method which we did now. Okay, for symbol pole, use the formula for symbol pole and you can apply, that is the formula is here, z minus a f of z. Okay, z minus limit z tending to a, this is a, okay. Limit z tending to a, z minus a f of z. You follow that, a is 1, then a is minus 1, then a is I minus I. So you can, also this z power 4 can be splitted into 4 terms, okay. You can remember, please remember so that you can cancel this term. Z power 4 means how many roots here? We have 4 roots. 4 roots for z power 4 minus 1. So if you have 4 roots here, what will you do? We can split the term as z plus 1 minus 1. So z plus 1, z minus 1, z plus I, z minus I. Then you can eliminate. Then you can substitute z as 1. For z you substitute 1 and you find the answer here, okay. A plus b into a minus b is a square minus b square. 1 square minus I square. I square is minus 1. So here you should follow that method. 2 into a square minus b square. That is 2 into 1 plus I square is minus 1. So 1 plus 1. I square is minus 1. So 1 plus 1. Then 2 into 2 you get 4. So denominator is 4, okay. Applying this formula, a square minus b square, you get 1 by 4 here. Okay, you can continue for other terms also. You can continue for z equal to minus 1, a equal to I, a equal to minus I, okay. And you can try it as a homework, okay. You can try this on your own.